Hey guys, welcome back. It's 9-5, adding and subtracting rational expressions. Now, to be perfectly blunt with you, this is probably one of my least favorite. I hated this one. Um, it's not bad. There's one thing I didn't like. So let's go ahead and get going because this is a critical skill for success in your future math classes. Okay, finding the least common multiple. And might I add, that is the least common multiple, which is the smallest number that both of these expressions would go into. Not the greatest common factor, which is the largest factor they have in common. The smallest number that they both go in, or that goes into them, whatever. You know what I'm trying to say. So the least common multiple. Okay, so step one is to factor down our expressions. So we've got 2x squared minus 8x plus 8. And we also have 15x squared minus 60. Okay, so over here, 2, 8, 8. So I know I've got a 2 that I can factor out. And we're left with x squared minus 4x plus 4. Well, this is a perfect square, and this is a perfect square. The square root of 4 is 2. 2 plus 2, or let me rephrase that. 2 times 2 is 4. So this is a perfect square trinomial. So we have 2 times x minus 2, x minus 2. Excuse me. Okay, 15x squared minus 60. We can factor out a 15. And we have x squared minus 4. Well, this one is a difference of squares. So we have 15, x minus 2, x plus 2. Okay, so now we want to find the smallest number that all of these would go into. We don't want to duplicate anything, and we don't want to leave anything out, right? So let's see, 2 and 15. 2 doesn't go into 15, 15 doesn't go into 2. The smallest number that 2 and 15 both go into would be 30. And you get that by doing 2 times 15 times, let's keep on going, and I'm going to check mark those because those are done. X minus 2, we have an x minus 2 in both of these. So I'm going to write that here, and I'm going to check mark both of these because we're taking into consideration if it occurs once on both. Then we have another x minus 2. Well, since there's 2 here, there have to be 2 here. And now this one's done. Looking over here, we have an x plus 2. Well, this one's going to have x plus 2. So now we have 2 times 15, which is 30. And then we have x minus 2 squared, or you can have x minus 2, and then x plus 2. This is your answer. You are going to need to know how to do this in order to add and subtract, because we're going to be adding and subtracting those rational functions, which are basically fractions with algebraic expressions in them. Okay, not skipping, but let's go on to the next one. And we have adding rational expressions. Textbook does a really good job of explaining this, so take a look at that if you still need some clarifications on some things. But essentially, it's the same thing that we had when we just did basic fraction addition, 2/3 plus 3/4. What do you have to have in order to add these two together? You have to have a like denominator, common denominator. So 3 and 4, the smallest thing they have in common is 12. So 3 times 4. See how that works? Okay, so let's go ahead and get started on this so that we don't spend a whole lot of time doing it. All right. Anytime I look at these, the first thing I want to do is see if I can factor anything in common out. And I want to write these rational functions as expressions. I don't want them to be a multiplied trinomial or a binomial. I prefer to have them as factors. So 3x squared plus 21x plus 30. Each of these has a factor of 3 in it. So I'm going to factor that 3 out. And we're left with x squared plus 7x plus 10. Well, this, thank goodness, is an easy one, right? Factors of 10, that would give me 7. Well, that's just x and 5. 5 and 2. All right, now we have that one completely factored down, so we're good. 3x plus 15. Thank goodness for easy ones, right? Let's divide out that 3. We have x plus 5. All right, let's go ahead and start putting it back into the addition problem. We have 1 over 3 times x plus 5, x plus 2, plus 4x over 3 times x plus 5. Okay, so in order to add these, we have to have like denominators. We have a 3 on both sides. We have an x plus 5 on both sides. This one has an x plus 2. This one does not. Therefore, we need to multiply this one by x plus 2 over x plus 2. What is x plus 2 over x plus 2? It's another way to write 1, right? Okay, so now in the denominator, we would have 3 times x plus 5 and then x plus 2. In the numerator, we have 1 plus 4x times x plus 2. We need to distribute this and clean it up, and then we're done. This particular problem isn't so bad. You'll see there's some really ugly ones in the future. Okay, 4x times x would be 4x squared. 4x times 2 is 8x. That means that our final answer will be 4x squared plus 8x plus 1 all over 3 times x plus 5 times x plus 2. It doesn't look like it's simplified or done, but it is done. Trust me, you're good. There's nothing you can do up top, so I wouldn't worry about that one. It is okay if that one is expressed as a trinomial. Okay, we have one final example for today for this section, subtracting. And you'll notice that there's a little typo here because it says subtracting, so this is supposed to be subtracting. And this is not a conover, oops, thank goodness, right, I do enough. So this should be minus. Okay, same principle as with the addition, obviously. We have to have the same common denominator, or the least common denominator, I should state. Okay, x squared minus 2x minus 3. Well, negative 3, or factors of negative 3, that would give a negative 2, would be negative 3 and positive 1. So that would be x minus 3 and x plus 1. Just to double check, x squared, positive x minus 3x. So that's negative 2x. Negative 3 times 1 is negative 3. 4x plus 4, factor out of 4, and we have x plus 1. Okay, let's go ahead and get a least common denominator. So we have an x minus 3, and we have x plus 1. So now these are taken care of. We have a 4, so we need to put a 4 down here, and we have an x plus 1. Well, x plus 1 is already down there, so we are good. 4x plus 1, 4x plus 1. Okay, now, on this one, I had to multiply it by a 4 to get this to be the same. So we're going to have to do a 4 to the numerator and then the 4 to the denominator, which we have down here. And then for the second term, 4 times x plus 1, well, in order to get this denominator, we have to multiply it by x minus 3, right? Okay, so now let's go ahead and put this in the numerator of our answer. 4 times 2x, 4 times 2x is 8x. And then we have minus, and I'm going to put parentheses right here. Since we're subtracting, it could affect the sign. It should. It will be the opposite of whatever we had. So we'll have 3 times x, which is 3x, 3 times negative 3, which is negative 9. So that would be a negative 3x and a negative 9, or opposite of negative 9, or minus and then negative 9, which gives us 8x minus 3x plus 9, because we distribute this negative all over 4 times x minus 3, x plus 1. 8x minus 3x is 5x. And it looks like that's the last thing I can do here. So 5x plus 9 all over 4 times x minus 3, x plus 1. And that ends it for today. So for those of you who don't like fractions, you're not going to like this. It's not bad, it's just you have to do the fractions just with algebra now. All right, that's it. If you have any questions, you know where to find me.